This is a worked example for a projectile motion question. So our example, a body is projected with a velocity of 200 meters per second at an angle of 30 degrees above the horizontal. If it is projected from the ground, calculate 1. The time taken to reach maximum height, 2. Its velocity after 16 seconds. Assuming gravity is 9.81 meters per second to the minus 2 and air resistance is negligible. Our method. Our first step has got to be to work out what we know from the question, and the best way to do that is to draw a diagram and put the information on the diagram. So, we've got something being projected from the ground. So there's the ground, and there's a thing being projected. It will take our parabolic path through the air, like that, to land back at the ground later on. We know that it's 30 degrees above the ground and that its speed is 200 meters per second. That's what we know so far. For the first question, it's asking for the time taken to reach maximum height. So that is going to be at this point in the arc. We're going to say that the height is our displacement in y. Now our first step for calculating the part 1, the maximum height, we should know that we're only working in the vertical direction. So we don't need all of this 200 meters per second, we need to split that into components. So we're going to have an initial velocity in y and an initial velocity in x. Using components, we can say that ux and uy are going to be that one. We've got the hypotenuse, so that's the adjacent. So ux is cos 200 times the cos of 30 degrees. uy is going to be the sine, because that one is the opposite in the triangle. So I've got 200 sine 30 degrees. So we consider vertical. We write down our variables, our things that we know. We want to know about S, U, V, A, T. It's always those 5 things. In this case, if we're considering vertically, we can put on our subscript. We can say it's SY, UY, VY, AY and TY. Now the time's the same in both cases. dy equals tx. And we don't know it. That's our unknown in the equation. We want to find out what the time is. Sy is that maximum height, but we don't know it. Uy, we've just worked that out, that's the component there, 200 times the sine of 30 degrees, which if I type in my calculator is 100 meters per second. Vy, the final velocity, we are only considering from the beginning to when it reaches maximum height. Well, when it reaches maximum height, its vertical velocity comes to 0 before it starts going down again. So that is 0. And its acceleration, we've been told, is 9.81 meters per second. What we need to be careful is what direction things are going in. Gravity is acting downwards, so it's a minus. So that downwards is a negative direction and upwards is our positive direction. So from not being told very much in the question, we've got all 4 of our things that we need to know about. We've got 3 bits of information and 2 things we don't know, one of which we want to find out. So that means we use no S equation. The no S equation, V equals U plus AT. Then we substitute in what we know. So we've got Vy is 0, U 100, A minus 9.81, T are unknown. We rearrange. 9.81 t equals 100. So we add 9.81 t to both sides to get rid of that and put it on that side. Dividing by 9.81 on both sides, we get 9.81 t divided by 9.81 is t, and 100 divided by 9.81 for our answer, giving us t equals 10.2 seconds. And that's our answer, the time to reach maximum height. So, second part of the question. It's asking us to find the velocity after 16 seconds. Now we should note that to reach the maximum height here is 10 seconds. So at 16 seconds, it's somewhere around there, isn't it? It's going downwards. So we can say that t equals 16 seconds. The body is past maximum height. So is travelling downwards. But more than that, we've said that air resistance is negligible. If air resistance is negligible, this value, ux, is not going to change. It's not going to be decelerated horizontally. So, as air resistance is negligible, ux equals vx, which we said was 200 cos of 30 degrees. So all we really need to find the velocity at this point, so we want that v there, which is made up of a horizontal component, vx, and a vertical component, vy. We know vx, we want to find vy, and then combine them to get v, the combined one. We must calculate vy. So again, we're only looking vertically. And we write down our variables s, u, v, a, t in the vertical direction. So y, we know that ty equals tx, which is 16 seconds, what it asked for in the question. We know that acceleration, minus 9.81 due to gravity. We know vy is what we are trying to find out, that's our unknown. We're still considering from the start uy 200 sine of 30 degrees. Which was 100 meters per second. And sy we don't know. So, again, that means if we don't know that, and that's not what we're trying to find out, we're going to use the null s equation for a second time. V equals u plus at. V, what we're trying to find out, u 100 plus minus 9.81 times by t 16, giving us minus 57.0 meters per second. Correct? Minus? Yes, it's going downwards, as we said. It's past the maximum height, it's travelling downwards. We would expect it to be a negative value. So, that is one component of it, v, y. We've got the other component. I've made a mistake with my subscript there. We've got the other component, vx, vy and vx were combined together using Pythagoras' theorem. So we'll say recombine using Pythagoras. V squared equals vx squared plus vy squared, which equals 200 cos of 30 degrees squared plus minus 57 squared. So combining those, square rooting, we get v equals 182.3 meters per second. If we needed to, we could use trigonometry, SOHCAHTOA, to find out what direction that was in at that point, because we've got the sides of the triangle. To recap, we had a question that's more difficult than the ones that we've been doing. All we did to break it down was some key parts. We drew the diagram. The diagram is an important part. It helps us to understand what we've got and what it is we're trying to find out and put it in a picture. Just like all of the previous questions, we've been writing down our variables, S, U, V, A, T, to try and identify what it is we know. Again, just like with the diagram, it's the key to making it clear what it is that we know, so we know what we're trying to find out. From that, identifying what variables we have and don't have tells us what equation we're going to use in exactly the same way as what we've been doing. So we still choose the equation in the same way. Our things that have made it more difficult, in this case, it's at an angle. And the angle means we've got to use components. But components we did in the last topic, and that was alright. It's still just one of them is cos, that's the one next to the angle, because it's the adjacent, and one of them is sine, that's the one that's not next to the angle, because it's the opposite. So, we've got a diagram with a list of variables. To choose the equation, we've used components. We also, though, split the motion into components. Just like we can say the velocity is in two components, the motion acts in two components as well. And the horizontal motion in this case doesn't change. There's no air resistance. So the only thing that's doing anything is the vertical component of the velocity. So by splitting the motion into components, that makes this problem easier to solve. And our last point, just like with other forces ones, where we split it into components to start off with, sometimes we need to recombine it, and we recombine using Pythagoras' theorem. All the steps are straightforward in themselves. It's putting them together. Putting them together is the diagram, and being clear and methodical in what it is that we're doing.